All right, thank you for joining us for how to subtract integers. How to subtract integers can be fairly confusing when you think about all the different processes that are happening. I'm going to start with some soup examples that we talked about in class, and then I'm going to spend most of my time just on solving problem after problem to see if you are able to follow along with us. What we want to talk about here is the fact that we have integers. Remember that integers are numbers that are our counting numbers and their opposites, and they range from the negatives, from like -10, we stop at 0 in the middle, all the way up to 10. Obviously they go further on each side in either direction. They go on for infinity, but they are our counting numbers and their opposites. No fractions, no decimals in between. So when we talk about our soup method, remember in class we were talking about these chefs who are making some soup. We had some magical cubes. The cold cubes never lost their coldness. They retained the same temperature. And the hot cubes never lost their hotness. They retained the same heat. And anytime I put in a hot cube or a cold cube into my soup, it would change it by 1 degree. So no matter what my soup temperature is right now, when I added this one cold cube, it changed by 1 degree down. It was 1 degree negative. And if I put this hot cube in, well, it raised my soup up 1 degree, and therefore it is back to where it started. So this is 1 degree colder, and a hot cube is 1 degree warmer, and they're both 1 degree. So in this particular example, we are talking about this chef who had to put in 6 hot cubes. So he's going to put 6 hot cubes into his soup. 1, 2, 3, 4, 5, 6. So mathematically speaking, when I look right there at that example, it's telling me that I have 6 hot cubes, again, which is a positive. So I have positive 6. And then chef number 2 came over and he took out. To take out means to subtract. And what am I subtracting? I'm subtracting 10 hot cubes. So I'm subtracting a positive 10. Now when I look at my pot, it's fairly obvious that there are not 10 hot cubes here to take out. So in order to create these 10 hot cubes, I need to add in a 0 pair. I need to add in some things that are not going to change the temperature of my soup, but will allow me to have what I need to take out. Now when I look here, I'm still at the positive 6 degrees that we started with. I added in some extra hot, so I'll be able to take my hot cubes out. But I didn't change the temperature because I also brought in the cold with them. When I look at this, a positive 6, take away 10. Now I can take away 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What's left over is a negative 4. So for some of you in class, you're going to sit down and say, okay, well, if I have 6 things, I can't take 10 away. If I try to take 10 away, I'm not going to have enough, and how much am I missing by? Negative 4. Another group of you may do this problem better, this negative 6 minus 10. I'm sorry, positive 6 minus a positive 10. You may handle this better by looking at a thermometer or a number line. I'm going to start with a number line, and I'm going to start at 0. And the first thing I need to do is add 6. 1, 2, 3, 4, 5, 6. Once I added 6 in, now it says that I need to take away 10. So to take away, I have to go back. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And where does this bring me? Well, this is 0, this is the negative direction. Negative 1, negative 2, negative 3, negative 4. So my answer would still be negative 4. There are still others of you who look at negative 6 minus 10 and just simply say, well, I have $6 and I can't take away 10. I need 4 more. And you can just subtract it like that. So what we're going to do again is just look at a few different examples and just see what we can get. See, hopefully we can figure out what's going on here. So in this example, we have the chef who put in 3 hot cubes. So it's positive 3. And he took out, the next chef took out, subtracted 8. Well, can I take away 8 if I don't have it? 1, 2, 3. Can I take away 8? No. In order to do that, I have to make sure that I have enough hot cubes inside. So I have to place some 0 pairs in there. Once I have my 0 pairs, I can take away my hots. 1, 2, 3, 4, 5, 6, 7, 8. And what am I left with? The 5 colds. So really what I can do is determine how many more hots do I need, and know when I take that away it's going to leave me with colders, with the negatives. Again, I can look at this with a number line or a thermometer. I'll use a thermometer this time. We'll start it at 0. It goes up 3 degrees, 1, 2, 3, so now we're at 3. And then it's going to go down 8 degrees, 1, 2, 3, 4, 5, 6, 7, 8. So we know we're at this line right here, and all I have to do is count and see where does that bring me. 1, 2, 3, 4, 5, negative 5. Again, the same answer that I had up here. I'm going to skip through some of these, and we're going to go here. Remember, you can always pause, write it down, and then come back. What I'm going to show you in the next few problems is how to subtract integers. In the next few problems, we're going to talk about how to subtract integers. Each of your teachers delivers this information a little bit differently. What I'm going to have you do right now for the video is write down this information as well. And then we'll go through a few problems. Again, hit pause, write it down, and come back. So subtracting integers is essentially like adding its opposite. So I want you to think about a few things, and let's look at a problem. We're going to start with one where the digits are slightly smaller. Let's try 2 minus 7. Think about having $2 and you have to pay someone back. So if you have $2, can you take 7 away? No, you can't. You're going to have to go into the negative and wait until you get $5 more. The other day in class we were talking about how to add integers, and I want you to begin to see that the problem to the left is exactly the same as this problem here, where I recognize the fact that this is a positive 2 as an integer and that this is a negative 7 as an integer, and I'm combining the two together. The same effect is going to happen. 2 and a negative 7 is going to end up giving me a negative 5. And once I recognize that and I'm able to use the additive inverse, I can make some of these problems a little bit easier to deal with. Excuse me. Pardon me for that. All right, so now if I'm looking at 5 minus 29, I can also see this as 5 plus a negative 29. Because this is going to bring me down 29, and that's going to bring me down 29. In class, we talked about setting up a diagram in which this positive 5 would state we had 5 positives, and this negative 29 would state that we had 29 negatives. Then using our knowledge of 0 pairs, we were able to cancel out and see what was left over. I know that I had 5 positives here that I could cancel out with these 5 negatives here. And then just count what I have left over. 5, 10, 15, 24. I had 24 negatives left over. Turning each one of these subtraction problems into an addition problem can make life a whole lot simpler and making subtracting integers easier to understand. So if I look here, I have a positive 6 as an integer and a negative 9 as an integer. So I have 6 plus negative 9. 6 plus negative 9, again, if I'm looking at my number line and I started at 0, I'd go up to 6. Here's 6. Then it says go back down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And where am I at when I'm here? Negative 1, negative 2, negative 3. Go ahead, try this next one by yourself. Unpause it and see if you got the right answer. So I would write this as an addition problem to look like that. I would ask myself, if I draw out the positives and draw out the negatives, what am I going to have more of? Well, I'm going to have more of the negative. And then how many more will I have? Well, that's just a case of subtracting these or counting up, whatever you need to do. And to get from 16 to 21 is 5. I want to give you another one to try. 17 minus 28. 17 minus 28. Hit pause and then come back. So now I have 17 plus a negative 28. Once again, I know that I'm going to have more negatives than positives, so my answer is going to be negative. How many more? I'll just subtract the 2, and I'll get 11. So there were a few other problems that we talked about, and one of them would be like this. So what happens if I started with cold cubes in my pot? So I want to draw that. Now my pot's going to be a square because it's just easier for me. And I started with 7 colds. Can I take away 5 positives? Can I take away 5 hots if I have 7 colds in there? No, because they don't exist. So I need to add in my 0 pairs in order to get the 5 hots to take away. Now there are 5 hots that I can take away, but what else did I do in doing that? I added in 5 colds. So what did I do to this problem? Instead of taking away 5 hots, I added in 5 colds. Now I have negative 7 plus a negative 5. Negative 7 and a negative 5 equals a total of 12 negatives, which is reflective in our graph over here. So you try this one. See if you can come up with an answer. Again, when I look at this one, I know this is a negative 6 plus a negative 2 because I'm going to add the opposite. In doing that, I know that there would be 6 colds and 2 colds for a total of 8 colds, or 6 negatives and 2 negatives for a total of 8 negatives. Try this. All right, welcome back. So now we have a negative 2 minus, I'm going to replace the a with a 5. Again, this is just the same as negative 2 plus negative 5. The additive inverse allows me to change this into its inverse. It's negative 5. Add them together to get negative 7. I will go back to a summary. However, I want to talk about a few more problems because I'm going to do the subtracting integers all at the same time. So let's start right here. I was trying to find one that had just, here we go, some smaller numbers to start with. So Chef 1, he's going to start with 5 hot cubes. 1, 2, 3, 4, 5. Now that's a positive 5 for my integer. He wants to take out or subtract cold cubes. Are there any cold cubes in here to take out? No. So I'm going to put in the cold cubes he needs to take out. 1, 2, 3. In this case, what do I end up doing? If I take out the cold cubes, 1, 2, 3, I actually made my soup hotter because that's what remains with my 0 pairs. So to take 5 minus a negative 3, it's actually going to make my soup hotter. For those of you who have your parents who are trying to help you, one thing that you can think about in this case is taking away a debt. If someone owed me $10 and I took away that debt, the money that they had would suddenly increase because they don't have to worry about paying me back. That debt was taken away. So this is like taking away a debt. And suddenly, if I had $5 and I had to take away negative 3, well, it doesn't work in this case. I have to switch around. But it's like taking away the debt that I owe someone. I suddenly have more money in the end. So in this case, we know that our answer is a positive 8. What I'm going to do is we're going to go look at a few problems, just naked number problems as we call them. I might have to add in a sheet here. And I want you to notice the pattern. If I had 7 minus negative 2, 7 minus negative 2, I'm going to go over here to my soup. I had 7 hots, 1, 2, 3, 4, 5, 6, 7. I want to take away 2 colds. I can't until I add them in, so now I can take away 2 colds. What did I really end up doing in the end here? I still had my 7 hots, but I added in 2 hots. So really this became 7 hots plus 2 hots. Alright, so let's look at another similar problem. 15 minus negative 10. So in my pot I had 15 hots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I need to take away 10 colds, but I don't have any colds. I can get the colds by adding in my 0 pairs. But really, what happens when I'm done turning in my 0 pairs with all these colds, now I can take the colds away. But really, all I did was add in some hots of the exact amount. So this turns into being the same thing as 15 adding in 10 hots instead. Are you noticing a pattern here? What if I had 12 minus negative 3? If I follow the pattern, that's going to be like taking that dead away, and it's going to be like adding. What if it was negative 9 minus negative 3? If I have 9 negatives, can I take away 3 negatives? I sure can. If I had a pot, and inside my pot were 9 colds, 1, 2, 3, 4, 5, 6, 7, 8, 9, can I take away 3? I can. What am I left with? 6 colds. However, I also want you to notice that negative 9 plus a positive 3 is going to result in the same answer. I have more negatives than positives, and I have more by 6. My answer is still going to get bigger. Yes, negative 6 is still negative, but it's bigger than what I started at with negative 9. So all of this is still following the same pattern, even though it looks a little bit different. Let's look at another one of those. What if I had negative 5 and I wanted to take away 2 negatives? 5 negatives minus 2 negatives. Think about it logically. If I had 5 of something and I take away 2 of something, I'm going to end up with 3 negatives. Same thing as negative 2 adding in, because I'm taking away that debt, so it's like it's going to increase. 5 negatives and 2 positives is 3 negatives. Just a problem after a problem. One thing I want you to see as I do this is I'm turning them all into addition problems, and that's okay. It's okay to turn them into addition problems. So let's go back and try not having the double negative and see if you remember. What if I had negative 5 minus 2? Well, remember, this would turn into negative 5 plus a negative 2. Because what is this saying? Start at negative 5 and go down deeper 2 more. You dropped 5 degrees, then you dropped 2 more. You're going to be down 7 at the end, so that's a negative 7. What if I had 5 minus 9? Well, I started in the positive, and I have to take away 9. I don't have 9 to take away, so I'm going to end up in the negative by how many? 4. Again, this problem could be written as 5 plus negative 9, and it would result in the same answer. It can be very easy to just take these problems and turn them into addition problems. Remember the additive inverse. So the summary, each of your teachers is probably going to give you a different summary that they want you to fill out. One thing that I like to note is thinking about it in a logical perspective is always the most helpful. So what we're going to do is we're going to try a few sample problems here. You hit pause, come back, and tell me how it goes. Alright, so you should have had time to solve this problem. I know right now that I am 5 degrees in the negative, and I need to take away 9 negatives. Ooh, so this one's a little bit different. If I only have 5 negatives, can I take away 9 negatives? Cold, 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 cold. No, I can't. I can't take away 9 negatives, so I'm going to have to add in some in order to fix that. Now, 1, 2, 3, 4, 5, 6, 7, 8, 9. Is there enough to take away 9 colds now? Yep. And what happened in this case? It became positive by 4 is what I meant to write. It became a positive 4. So now when I see this, I can also look at this as a negative 5 plus a positive 9 because I'm going to add the opposite, add the inverse. When I do that, it becomes a 4. And again, it's just naturally thinking of what's going to happen. If I owed someone $5 and I had to take away a debt of $9 that I owed somebody else, well, then I'm in the money 4. Let's say I came across some money. I'd be in the positive 4. All right, so now I have 8 negatives minus 4 negatives. If I have 8 negatives, can I take 4 negatives away? I sure can. I'm going to end up with 4 negatives. But to be consistent, let's turn this into an adding the opposite problem. So if I add the opposite, I end up with a positive and a negative. Negatives are going to win by 4. Hit pause, come back. All right, so now I can work in this different ways. I'm going to start here and work this way. I have 4 minus 5. If I have $4, can I take 5 away? No, I can't. So I'm still going to change this into an addition problem, again, just to keep things consistent. And now I have 4 plus a negative 5. 4 plus a negative 5, the negatives have more, so they're going to win by 1. Now that took care of this part of the problem, but I still have this minus negative 9 on this end. So this, again, I'm going to turn it into add the opposite problem. And I'm going to end up having more positives than negatives, so my answer would be positive 8. All right, once again, 3 negatives, can I take away 4 negatives? Well, if I only have 3 negatives, I can't take away 4 negatives. So it's going to turn into this adding of the opposites. And then I'll carry this 1 down. And then I'll also have 3 negatives, 4 positives, which will result in 1 positive. And 1 positive, take away 1 is 0. I know that subtracting integers can be frustrating and overwhelming, but let's look at the few sample problems we've learned. We've learned about how to take a number and subtract another integer smaller than that. We've learned how to take an integer and subtract a larger integer from it. We've learned how to take a negative integer, again they're all integers, and subtract a number from it. And a negative integer and subtract a larger integer from that. And we've learned how to take an integer minus another negative integer. So we have these 5 different subtraction of integers that we have completed. 5 minus 2 is something that you've been doing since you were very young, first, second kindergarten, and you just subtract them. In this case, something we've moved on to is that if I have 5 things, I can't take away 8. If I have 5 things, I can't take away 8 because I'm missing 3. I can turn this into an adding the opposite problem, and as I look at this, I realize that my answer would be negative 3. Here's the next problem, negative 6 minus 2. This negative 6 minus 2 can be written as an addition problem of negative 6 plus negative 2. If all of these are negative and all of those are negative, my answer would be negative 8. Negative 6 minus 9. Negative 6 minus 9, this can be turned into an addition problem of negative 6 plus negative 9. And that is also then going to give me an answer of negative 15. See, even teachers make mistakes. And last but not least, I have this problem where I'm going to turn it into adding the opposite. The negative 5 stays the same, and I'm going to add the opposite to give me a negative 3. In summary, I think it's easy to recognize that as subtraction problems can be changed into addition problems by using the additive inverse. Thank you very much, and good luck on your homework.